Hello everyone, welcome to day 17 of Hot Summer series. Today we are going to solve questions on two of the topics of algebra, which are series and progressions and logarithms. So these are crucial topics of algebra, and you definitely get a question or two from these topics. If you see the past year papers of last 6-7 years, you will definitely find a question from either these indices and logarithms, and one on series and progressions. So it's a short question. Let's solve a variety of questions from this topic. If you are new to the channel, please don't forget to subscribe to the channel for great content on MBA preparation. So this is the schedule. We have completed 16 classes thus far. Today is class 17, and I am sure by now you must have learned a lot of new things, how to solve questions in innovative ways, a lot of techniques related to all the three sections. And please continue watching this series, and I assure that if you watch all the 30 videos and apply those techniques in solving questions, you shall definitely do much better than you have been doing till now. If you are preparing for CAT and are looking for a structured preparation, or know someone who is preparing for the same, you can recommend them to our CAT course. And in this you get classes along with practice sheets, doubt resolution, full length and sectional mock test, plus GDPI preparation. And one can use a code HOT to get 20% off till the end of this month. So let's begin with the first question. It says that Rakhu borrowed some money from his friend Akash to admit his daughter to a reputed B school. He agreed to pay the interest-free loan. So there is interest-free loan. So you do not have to think of simple interest or compound interest, of 6 lakh in a monthly installment, which increased by constant amount. So increased by constant amount, that means that it is a arithmetic progression. Indirectly mentioned, it is not mentioned that it is an arithmetic progression. It says increased by a constant amount, that means it's an AP. After the 20th installment, he found that he had paid 3/4 of the loan. If the entire loan was cleared in 25 installments, find out the value of the first installment. So let us use the general notations. So general notation is, the first term is A. Okay, common difference is D. Okay, so now we are given that in 25 installments he paid the entire money, and after 20th installment he had paid 3/4 of the loan. The loan was 6 lakhs and 3/4 of the loan is 4.5 lakhs. Okay, and after 20th installment, so sum of n terms is, Sn is given by n by 2, 2a plus n minus 1 b. Okay, that is the sum of n terms. So we will get two equations. One is after 20th term, S20 and S25. So let us form the equations. S25 will be simple, 25 by 2, 2a plus 24d. Okay, where a is the first term and d is the increment that he is having. So that is equal to 6 lakh. So let's just convert into 2000s. So you can write 600,000. Okay, because these are values that are given in hundreds or so. So let us take 1000, 600,000. Okay, so we will get, this gives us 2a plus 24d is equal to, this is 12.5, and 8 gives 100, so this is 48. Okay, so 2a plus 24d is 48. Now sum of 20 terms is 4.5 lakhs. So 20 by 2, 2a plus 19d, that is equal to 450,000. Okay, so this gives us 2a plus 19d is equal to 45. Okay, so when we subtract, we get 5d is equal to 3 or 3000. So d is equal to 600. Okay, so now we will put d as 3 by 5 in any of the equations. 2a plus 19d is, d is equal to 0.6, and that is in thousands. Okay, so 2a plus 19d is 45 So this is 2a plus 11.4 is 45, 2a is 33.6, or a is 16.8, so 16.8 thousands. So the answer is 16,800. So two equations from two cases, solve for the first term, you get the answer. The sum of two n terms of AP is greater than the sum of n terms of this AP. What is the smallest value n can take? Again a question based on sum of n terms of an AP. So n terms, sum of two n terms is 2n by 2, 2a plus n minus 1, and d is 2. Okay, or we can write 2n minus 1 is greater than n by 2, 2a is 112 plus, sorry, this common difference is 4, plus 2 times of n minus 1. So this is, since there are two n terms, sorry, this is 2n minus 1, because we are taking sum of two n terms. So n by 2, that is here n is 2n, 2a plus 2n minus 1 into common difference, n by 2, 2a plus 2 times of n minus 1. Okay, so n by 2 is common, so we get 4a plus, this is 2, 4, 8, 8 plus 8 into 2, 16n, minus, this is 4 and 2, 8, minus 8 is greater than 2a is 1 here, so let's put is greater than 112 plus 2n minus 2. Okay, so we will get 14n is greater than, this is minus 4, 110 and 114. So n is 8 point something, n is greater than 8 point something. Now n has to be an integer value, so minimum value it can take is 9. Okay, so that is how we solve this equation. Quite simple one. You just have to apply the formula of sum of n terms and create the inequality that it should be greater. Now you get the value of n as 8 point something, so n has to be greater than that, since n is an integer value, so it has to be 9. Let the first term and the common ratio of a geometric progression be positive integers. If the sum of squares of its first three terms is 33033, what is the sum of these three terms? Now this is a good question. So we are given that the first term is a, let's say the second term is ar and the third term is ar square. It says the sum of the squares of its first three terms. So we are given a square plus ar square plus a square r to the power 4, that is equal to 33033. So we need to find this geometric progression and find the sum of the terms. Now this is a good question, it requires your understanding of numbers. So we will take a square common, 1 plus r square plus r to the power 4, that is equal to 33033. Okay, so one thing that one must consider here is these are all positive integers. It is given that these are positive integers. Now this should be divided by a perfect square. Another thing that one must know is if a number is of the format ABC, it is divisible, it is basically ABC into 1001. Okay, and that 1001 is basically 7 into 11 into 13. Okay, so ABC into, now here A is 0, 33033. So basically this number is 33 into 7 into 11 into 13. Okay, so that's how we break down this number. This was the key here, like finding the factors in this manner. Now if you found the factors, the question becomes simple. So it is 3 into 7 into 11 square into 13. Now we need to have a square, and these are both positive integer. So a square is 11 square. So a will be 11. Now we are left with the remaining part, 1 plus r square plus r to the power 4. That is 3 into 7 into 13. 13 into 7, 91 into 3, 273. Okay. Now you do not have to solve this by quadratic equation. Just think of fourth powers, right? 2 to the power 4 is 16. 3 to the power 4 is 81. 4 to the power 4 is 256. So r equal to 4 fits here. Because if you take higher values, it would be much higher number. So r is 4. Right? You do not have to write equation and solve it. Just use integer values. Now 11 and 4. So we need to find the sum of terms. So first term is 11. Second term is 44. Third term will be 176. Adding this, you will get 220 plus 11, 231. So that is the answer to this question. It was not a difficult question, just that it tests your ability to solve number based problems. Okay, so let's look at the next question. It says find the sum of this infinite series. Now this is called AGP. So we did a few questions on arithmetic progression and geometric progression. This is called AGP, arithmetic geometric progression. Now how do we solve this question is, so let us say the sum is 1 plus 3 by 4 plus 5 by 16 plus 7 by 64 plus 9 by 256 and so on. Now why this series is called AGP? Because half part of the term is following arithmetic progression. Like if you see 1, 3, 5, 7, 9, these are AP. But if you look at the denominator is 1 by 4, 1 by 16, 1 by 64, 1 by 256 and so on. That is forming a GP. Okay, so this is a mix of arithmetic and geometric progression. So AGP. Now let's see how to do this. So what we do is s is this. Now multiply s with the common ratio. What is the common ratio here is 4. So multiply it by 1. Sorry, the common ratio is 1 upon 4. So multiply s by 1 by 4. So 1 by 4 s. Now see what do you get. Multiply this by 1 by 4. You will get 1 by 4 plus 3 by 16 plus 5 by 64 plus 7 by 256 and so on till infinity. Right, now subtract this. So it's very simple, you just need to multiply by the common ratio and then subtract. So when we subtract, it becomes 3s by 4 and this is equal to 1. 1 comes as it is. Now notice this, we get a term like 2 by 4 plus this is 2 by 16 plus 2 by 64 plus 2 by 256 and so on. So basically you can say that it is 1 by 2, 1 by 8 and so on, right? So this is 1 plus 1 by 2 plus 1 by 8 plus 1 by 32 plus 1 by now this is a GP, right? This is a decreasing GP, infinite GP. What is the sum of infinite GP? A upon 1 minus r, where a is the first term and this is the common ratio. So that will be 1 plus 1 by 2 upon 1 minus r is 1 by 4, right? We are getting this product as 1 by 4. So 1 minus 1 by 4. So this becomes 3 by 4 and 1 plus 1 by 2 into 4 by 3. So basically 1 plus 2 by 3, which is 5 by 3. Okay. So we get 3s by 4 is 5 by 3. So s is equal to 5 into 4 by 3 into 3, which is 20 upon 9. So that is our answer. So if you ever get AGP, this is the way to solve. Very easy. Just write the series s, multiply s by the common ratio. When you subtract, you will get a constant term, okay, plus an infinite GP, okay, and find the sum of that infinite GP and solve it. So let's do another question on the same concept so that you get comfortable with this topic. It says if the sum to infinity of the series is 35 by 16, find the value of x. So we shall apply the same thing which we did in the previous question and solve this one. So we need to find the sum to infinity of this series. So let us say the sum is s 1 plus 4x plus 7x square plus 10x cube plus and so on. So it will be 13x to the power 4. We can generate the next terms and so on. Now if you take, what is the common ratio here? The common ratio is x. So x times of s is equal to x plus 4x square plus 7x cube plus 10x to the power 4 plus and so on till infinity. Now when we take the difference of these terms, so we get s common, 1 minus x, that is equal to 1 will remain as it is and just take the difference. So it becomes 3 times of x plus 3 times of x square plus 3 times of x cube plus and so on till infinity. Now let's summarize this sum. Okay, so this is 1 plus 3x upon a upon 1 minus r. 1 minus the common ratio is x. So it basically becomes 1 minus x plus 3x. 1 plus 2x upon 1 minus x. Right. So this is s times of 1 minus x is this. So what is x? What is s? S is 1 plus 2x upon 1 minus x ka whole square, and this sum is given as 35 by 16. Okay. One way here is to just put in the options and answer it. Okay, that's one way of answering this question. Another way is solving the equation. So let's solve the equation. You can put options also and check. That would also give you the answer. So this becomes 16 plus 32x is equal to 1 minus x ka whole square, that is 1. So 35 minus 2x minus 70x plus x square, so plus 35x square. So we'll get a quadratic equation which gives us 35x square minus 70 minus 32 minus 102x, and this is 35 minus 16 is 19. So plus 19 equals 0. So that's what we will get. Now if you look at this equation, how do we solve this equation is, this is 35, so we can say 7 into 5, and this is 19. So if you think of factors like 19 into 5 is 95 and 7. 95 and 7 is 102. Okay. So 35x square minus 7x minus 95x, okay, plus 19 equals to 0. So when you factorize, you will get 7x 5x minus 1 minus 19 5x minus 1, that is equal to 0. So when you solve it, you get x equal to 1 by 5 comma 19 by 7. Okay. Now some of you might say that there are two answers. Why is only one of the answers given in the options? So whenever we have an infinite series, infinite GP, so the common ratio is, the magnitude of the common ratio is less than 1, right? Because if the common ratio is more, it will be more than 1, we cannot converge, right? It will keep on expanding. So the concept of infinite GP is that the subsequent terms are smaller than the previous terms, and hence we can converge the sum to a given value. So we will reject this value, and hence our answer becomes 1 by 5. Okay. So if only 1 by 5 was given, then it is easy to answer. But if let's say an option says 19 by 7, both 1 by 5 and 19 by 7, their students get confused. They can make a mistake by marking both as the answer, but the answer will only be 1 by 5. It has to be less than 1. So I hope you are enjoying this session. Please don't forget to like this video. Let's now proceed to the next question. it says A, B, C, D are in HP, then AB plus BC plus CD is equal to. Okay, so these are the most boring questions that you would encounter, and they can be done in a very quite simple way. See if no constraint is given. Simple values. First of all, you should think of AP, GP कुछ भी बन रहा है. Take the terms 1 1 1 1. Okay. But if you take 1 1 1 1, this will be 1 plus 1 plus 1, that is 3. Okay. So this becomes 3. This is 2 plus 2 4. This is 3 and this is 4. So definitely these two are not the answers. So it has to be one of these two. So let us change the terms. We will not take 1 1 1 1 1. So HP is what? HP means that the inverse terms are AP. So for example, let's say 1 2 3 4, these are in AP. So HP will be 1 1 by 2 1 by 3 1 by 4. This is HP. Okay, so let's take this HP 1 1 by 2, A, B, C, D. Let's take this and solve this equation. So AB plus AB is 1 by 2, BC is 1 by 6 and CD is 1 by 12. Right, so let's add this. So this is upon 12, 6 plus 2 plus 1, which is 9 by 12 or 3 by 4. Okay, 3 by 4. Now one of the options is 3AD 3AC. 3A is there. Okay, and we need to multiply by 1 by 4 to get it, right? So 1 by 4 is D. So the answer will be 3AD. So that is our answer. Okay, so like it was very simple. Just take simple values and solve it. So if at all a question is asked on that this is an AP, you get two like simple values 1 1 1. If they say that the numbers are different, take 1 2 3 and test with the options. So this is the way to solving these questions. If you go by the conventional way, finding the notations, finding the relation between A, B, C, D, that's going to eat up a lot of time. So just simply take simple numbers as values and solve the given equation. Now here's the next question. It says a geometric progression has 6 terms. The first term is 192 and the common ratio is 1.5. An arithmetic progression has 21 terms and a common difference of 1.5. Given that the sum of the terms in the geometric progression is equal to the sum of all the terms in the arithmetic progression, find the first term of the arithmetic progression. So this requires you to solve the formula for the sum of AP and GP. Okay, so the sum of GP is A r to the power n minus 1 upon r minus 1. Okay, so that's the sum of like where r is the common ratio and n is the number of terms. Okay, so let's see this thing, that what's the sum that we get in this series. Okay, so let's put this value and find the value, so let's find this value. S is, we need to find the sum and we need to equate to 21 terms and has a common difference of 1.5, right? So S is given by first term is 192, then 1.5 is the common ratio raised to the power 6, okay, and minus 1 upon 0.5. Okay, now finding 1.5 to the power 6 could be a tricky task. So one thing can be done is you can simply multiply by the terms and get the answer, because that is a better way rather than finding 1.5 to the power 6, because like we can find the square, we can find the cube, but the sixth power is a big task, isn't it? So let's do one thing, let's find the numbers manually. So this is actually the formula for sum, but even if you apply some identity, that is a cube minus b cube or a square minus b square, still you will get the terms in decimals. So let's find the numbers directly. So 192, second term will be 96, add color 288, 432. Okay, then fourth term is 216, add to it 648. Then we will have 324, that is 972, and we can have the last term as 486 added to it. 486 into 3 is 1458. Okay, so that's what we will get as the terms. So let's add these terms. So this is 10, 10, 10, 30, 3 carries, 12, 20, 23, 27 plus 12, 39, 3 carries, 6, 10, 16, 16 plus 13 is 29, then 2 plus 1 is 3. So 3990 is the sum that we will get for this series. Right? Manual calculation would take a lot, like this formula based calculation might take a lot of time. We can do it manual calculation. Now this is that arithmetic progression has 21 terms, right? Now we need to find the first term of the arithmetic progression. Remember that sum of, like, average of AP is middle term. This notation, if you understand, it helps you solve a lot of questions, not to find the entire like formula, put the formula and solve it, right? So middle term is average of AP. There are 21 terms, so 3990 divided by 21 is equal to 21 into 1 is 21, 18, 189, 190. So that means 11th term is 190. 11th term is 190. Common difference is 1.5. So that means A plus 10D is equal to 190, right? So this is 15. A plus 15 is 190, or A is 175. It was a manual calculation based question, mechanical calculations. Okay, just that the formula you must understand. It is better to calculate manually than applying the formula, because we cannot find 1.5 to the power 6 without a calculator, because it will go deep into the decimal places. You will get 6 decimal places, right? And that is tough to write and calculate. Then this thing needed to be applied, that average of an AP is the middle term. If you know this property, this will help you in a lot of questions. Even in time and work questions, they say that a person, like the number of people keep increasing every day, right? So the average gives the middle term. Average work is, it will give you the middle term. Alright, so here's the next question. It says A, B, C are 3 distinct real numbers in GP, and A plus B plus C is X into B, then X cannot be. So you need to tell which of the following cannot be the value of X. So we are given the numbers A, B, C. So let us say the numbers are A and AR plus AR square. Okay, that's how we note them, is X into B. So X into AR. So we can take A common, and so it becomes 1 plus R square, that is equal to AXR. So we have to find the value of X, right? So we will put the value of X. So this X becomes 1 upon R plus 1 plus R. Now see this, like if you are given an expression, if you are given an expression a plus 1 upon a, if a is positive, so this is greater than equal to 2, right? You can take any value. If you take 1 and 1, it will be 2, and if you take greater than 1, it will be greater than 2. And if a is negative, then it is less than equal to minus 2, right? So we see that if r is positive, r is negative, so x is going to be greater than equal to 3, because it is 2 and this is 1, and this is minus 2 plus 1 minus 1. So x is either greater than equal to 3 or less than equal to minus 1. So minus 3 is permissible, right? 3 is minus 2 is permissible, 4 is permissible, 2 is not possible. Okay, so we have to use this inequality thing. It's a very common inequality which is often tested in the examination, that if you get an expression of this sort, the sum is, minimum sum is 2. The sum is obviously greater than equal to 2. So x, the value of x, if this is positive, the value of x is going to be greater than equal to 3. If it is negative, then x, the value of x is going to be less than equal to minus 1. So it, like, x ranges from like minus 1, minus infinity to minus 1, and 3 to infinity. Okay, so no numbers in between. So 2 lies in between them, hence is not an acceptable value. Okay, so those were some questions from AP-GP. Now let's solve some questions on logarithms and indices. So we are given 33 raised to the power a is equal to 11 to the power b is equal to 81. What is the value of 1 upon a minus 1 upon b? Now in such questions, you think that okay, 33 to the power a, I cannot solve, I don't know the powers of 33 or powers of 81. You will say that 81 does not come in powers of 11, right? So what we do in this case is, we need to equate to like, see, 33 to the power a is equal to 81. It implies 81 is equal to, like, 33 is equal to 81 raised to the power 1 upon a. Similarly, 11 raised to the power b is 81. It implies 11 is equal to 81 raised to the power 1 upon b. Okay. Now when we notice this value, what we see here is 33 and 11. What is the relation? 3 times 11 into 3 is 33. Or if we divide 33 by 11, we will get 3. Now, does 3 have any relation with 81? Yes, it has. So when you divide this equation by it, so you will get 3 is equal to 81 raised to the power 1 upon a upon 81 raised to the power 1 upon b. So when you have division, you subtract the powers. So 81 raised to the power 1 upon a minus 1 upon b. Okay. So now if you see this, so 381 is basically 3 raised to the power 4. So 3 is 81 raised to the power 1 by 4. So this becomes 81 raised to the power 1 by 4. Hence 1 upon a minus 1 upon b is 1 by 4. So that's how we solve these questions. Simple way to solve, just that we often think that these have to be integer values. Not necessary that we get integer values for a and b. Okay, so here's the next one. It says 4 to the power 3 plus 6 plus 9 plus 12 plus and so on up to 3x is 0.0625 raised to the power minus 117. What is the value of x? So we are given an arithmetic progression here and a power is given here. So we will use the power of indices. So this is basically 1 by 16. This is 1 by 16. So this expression is 1 by 16 raised to the power minus 117. So 1 by 16 is 4 to the power minus 2. 4 square is 16. So if you take minus power, it becomes the reciprocal. So that means 4 to the power minus 2 raised to the power 117. So that is 4 raised to the power 234. That's what we will get. Now this expression is 4 to the power 3 plus 6 plus 9 plus and so on up to 3x, right? So that is equal to 4 to the power 234. So we can say 3 plus 6 plus 9 plus and so on up to 3x is 234. So 3 times 1 plus 2 plus 3. Sum of first n natural numbers is x plus 1 by 2. 234 by 3. This is 78. This so if you take it this side, this becomes 78 into 2, which is 156, right? So x, we can say x is 12, because 12 into 13 is 156. The value of x is 12. So simple question, you just need to know the expression, that how do you find the sum of first n natural numbers, okay, and converting this power like 0.0625 to 1 by 16, which is 4 to the power minus 2, and hence solving the equation. So I hope you are enjoying this session thus far. So don't forget to like this video and share it with your friends who are preparing for CAT. This will help clear a lot of concepts and practice a variety of questions. Now we will solve questions based on pure logarithms. Okay. So now this is a question based on digits in an expression. So the number of digits in an expression is given by, so if you take log of a number, so let's say log a is b plus xyz, so that means number of digits is equal to b plus 1. Whatever comes before decimal, okay, it has one more digit. So let's say some log value is 3.57, anything, it can be 3.57, 3.03, anything. So that means number of digits is 4. Okay, so that's what we get as the answer. Okay, now we are given that log 13 is 1.114. So we can see that this is 1, so it has 2 digits, right? It is 0 point something, so it has 1 digit here. So we need to find the number of digits in 351 raised to the power 24. 351 is a big number, and raising to the power 24 is even difficult one. Okay, so let's see this. How do we find it? So 351 will have to think in terms of 13 and 3. So if you divide 351 by 13, we get 13 2s are 26 and 9 91 7, so 27. So can we say 351 is basically 13 into 3 cube, right? Okay, so what we do is we will find a log of this expression. Log of 351 raised to the power 24. Now if we have something in power here, so we will bring it this side. So it becomes 24 times of log 351, or we can say 351 is 13 into 3 cube. So we can say that 24 log 13 plus this is, or we can say this is 27. Okay, right, let's write 27 here itself. So 24 times of log 13 plus log 27. Log 27 can be written as 27 is 3 to the power 3. Okay, so that will be equal to 24 times of log 13 plus 3 log 3. So now we are given these values. Let's put these values and solve it. So 24 times of log 13 is 1.114 plus log 3 is 0.477. So 3 into 0.477. A bit of calculation is needed here. 24 times of 1.114, and this is 77 into 3 is 231 to carry, so 1.431. Okay, so and we have to multiply this by 24 to get the result. Okay, so 24 into 5 is 120, 12 carries 120, 12 carries 9608, 10 carries 120, 130, 13 carries, that is 61. Right, so you will get the value as 61.08. And if the value is 61.08, the number of zeros has to be 62. So this is how we solve this question, right? Although the values, the number here was a large number, usually you would given a smaller number. Okay, so solving log, finding the log of that given expression, and whatever we get the log value, add 1 to that Abesca part. This is called Abesca. So that is 62 here. The value of log 770 raised to the power minus 1 plus log 4 4900 raised to the power minus 1 plus log 570 to the power minus 1 is. See, one thing which is very crucial property in logarithm is changing to the same base, right? Changing to same base means that, see, here is log 7, here is log 4, log 5. So if you are given log b, like log a c, a b, anything like that, so that is log b upon log a. Okay, so solve it like this. Like for example, this will become log 70 upon log 7. Okay, and this entire thing is raised to the power minus 1 plus log 4900 upon log 4 raised to the power minus 1 plus log 70. Now you could have directly written also this way, okay, because we have to take the inverse of reciprocal of this, so it becomes log 7 by log 70 plus log 5 by log 70 plus this is log 4 by log 4900. Okay, so let us see this thing. So if you see this, log 4 is what? 2 square, and this is 70 square. Okay, 4900 is 70 square. So when we have something in power, it comes this side, it will become 2 log 2 and it will become 2 log 70. So on simplification it becomes log 2 by log 70. Okay, so now we have addition. Addition means multiplication. So log of 7 into 5 is 35 into 2, 70 upon log 70, which is simply 1. Okay, so simplification based questions are quite prevalent in logarithms. You will often find questions on simplifying the expressions. So you need to know the properties of logarithms. Please go through the properties, right? Write the properties in your formula notebook. I would recommend that some people share their formula notebooks on social media, right? Some influencers and all. Please do not download any formula notebook, whether it is by any institute, or even if you download those, maintain your own formula notebook, because when you just collect PDFs, that is not going to help you. ठीक है, जितना PDF ये सब जमा करते रहोगे कोई काम नहीं आएगा. Unless you write things on your own, you won't understand things. So write all the properties of logarithms. Try to solve as many questions on logarithms. Past year papers, every year you get questions on logarithms, and hence you can master this topic. Now we have a logarithmic equation which is again asked in examinations. So we are given log 9, this is equal to 2, you need to find x. This is called nested log, right? Log ke andar log. Now log, what is the expression? Like if we have log ab is equal to c, it means that a to the power c is equal to b. That is what is the conversion of log. So log 9, this is equal to half. So that means this part should be 9 to the power half, which is equal to 3. So let's write this: 3 log 2, 1 plus log 3, 1 plus 2 log 2x is equal to what we said, 3. So this is 3. So this becomes 1. Okay. this becomes 1, that means this log 2 is 1, so this is 2 to the power 1. Okay, so that is equal to 2. So 1 plus log 3, 1 plus 2 log 2x. Okay, so this is equal to 2. So this is again 1. Now this is 1, that means this is 3 to the power 1, that is equal to 3. So 1 plus log 2, 1 plus 2 log 2 x is equal to 3. So this is 2, this is 1. Okay, so when you subtract 1 it becomes 2. So 2 log 2x is log 2x is 1, so x should be 2. So just to confirm, right, because we did a lot of cutting directly, like instead of division writing an extra step, I cut directly, so I'll verify it. So log 2x is 1, so 1 plus 1 is 1 plus this is 1, 1 into 2 is 2, 2 plus 1 is 3, log 3 is 1, 1 plus 1 is 2. Okay, log 2 is 1 and into 3 is 3, log 9 3 is 1 by 2, so it matches. So the answer is 2. Okay, so nested log, one after other you have to calculate it. So I have cut down the steps, like for example log 1 plus log 3 I took it 2, so I cut it and made it 1. Okay, similarly it was 1 plus log 2x. I mean, to understand this, this is 1 plus log 2 log 2x. So 2 log 2x would be, subtract 1, that is 2, then I took 2 common, it is 1. So log 2x is equal to 1, so that means x is equal to 2, and we verified also by putting into the given expression. Okay, so nested log equation is another common variety of question which is often tested in the examinations. Well, let's do the next question. This is log 5x, log x 3x, log 3xy is equal to log x cube. Find the value of y. Now, I told you the most common thing in logarithms is the one which people often find difficult is change of base, right? So whenever you have different base, like here the base is 5, here the base is 3, here the base is 3x, here the base is x, different bases. If you have same basis, then you apply properties of multiplication, division, etc. But you have different bases, then you convert it to this format, like it will be log x upon log 5 to natural base, okay, and then it is log of 3x upon log of x, and it is log of y upon log of 3x, and this expression log x to the power 3. So x cube is 3 times of log x. So this expression, right hand side expression is 3, so it becomes 3 this side. Okay, log x is 1, so this expression is 3, this equal to 3. So it's a simple one. So these gets cut off. So log y upon log 5 is equal to 3. Okay, so log y is equal to 3 log 5. So that can be written as log of 5 to the power 3, which is log 125. Log 125, that means y is 125. Okay, very simple one. Just understand that if you are given different bases, you convert to a common base, natural base. How do we convert? Whatever is given in this this argument, take in the numerator, log of this, and whatever is given in the base, take this in the denominator, and then just multiplication, division, whatever is needed, execute and get the answer. Okay, so let's do this next question. It says that we are given two values x and y. These are positive real numbers. Okay, positive real numbers, so they have to be positive numbers. Log 5x plus y plus log 5x minus y is 3, and log 2y minus log 2x is this. You need to find x into y. So first equation, log 5 x plus y plus log 5 x minus y. So when we are given the same base in the logarithms and we have addition, so that means we need to multiply the terms. So log 5 x square minus y square is equal to 3. So 5 to the power 3 x square minus y square is 125. Okay. Now there could be multiple values that would give you x square minus y square is 125. Let's find the second equation. So it says log 2y minus log 2x. So it means that log 2 y upon x, right, log a minus log b is log a upon b. Okay, so whenever plus sign is in between them, same base, so we multiply, same base minus sign we divide. 1 minus log 2 3, 1 minus log 2 3. Okay, now how do we solve these equations wherein we are given a constant? So we will take log 2, we will convert it in log 2. So 1 is equal to log 2. Okay, suppose it was, let's just take an example, it was 5 minus log 2 3. Okay, suppose you have to solve this equation. So what we need to do is we make log 2 2, because log 2 2 is 1, so that would become 32 log 2 32. That will convert 5 into this. Okay, so basically if you are given a constant and a logarithm value, okay, so convert it by like let's say it was 5 minus log 2 3. Okay, so we took 2 to the power 5. So here it is 1 minus log 2 3. So we will make it 2 to the power. So log 2 2 minus log 2 3. Okay, so this means that is log 2, and this becomes numerator, this becomes denominator, 2 by 3. So we see the same base here. So y upon x is 2 by 3, right? So let's say x is 3a and y is 2a. So x square minus y square will be 9a square minus 4a square, that is equal to 125. So this gives us 5a square is 125, or it gives us a square 25, or a is 5. If a is 5, x will be 15 and y is 10. You can verify x square minus y square, like 125, you will get the answer. So we need to find the value of x, y. The answer is 150. So solving log equations using the log properties and then finding those variables and multiplying them to get the result. If x, y, z are positive real numbers such that x to the power 12 is equal to y to the power 16 is equal to z to the power 24, and three quantities 3 log y x plus 4 and 4 log z y and log x z are in arithmetic progression, what is the value of n? Okay, so this is a very good question, and typically you get these kind of questions in the exam also. So always remember that if 3 terms in AP, suppose ABC are in AP, so the relation is A plus C is equal to 2B. And also remember this, although this is about AP, I am explaining about GP also. If you are given that ABC are in GP, so that means AC is equal to B square. Okay, so keep these things in mind whenever we are given that these 3 terms are in AP or GP. So these 3 terms are in AP, that means sum of these will be equal to twice the sum of these. So basically 3 log y x plus n log x z is equal to 8 times of log z y. Okay, that is the equation that is given to us. Now we need to find the value of n. Now how do we find the value of n is, x to the power y, so x की power 12 is equal to y to the power 16 is equal to z to the power 24. Okay. So let's take LCM of these. What is LCM of 12, 16, 18, 24? That is 48. So let us substitute as k to the power 48, where k is any other variable. So this means x is equal to k to the power 4, y is equal to k cube, and z equals to k square. Now this will solve our purpose. Okay, now we can put in the values. So 3 log y is k cube and x is k square, k4, plus n times of log x is k4, z is k square is equal to log 8 log zy, z is k square and y is k cube. Now this is easy to simplify. Now see this, if we have a power here, that comes to the left hand side. If you have power here, that comes to the left hand side with 1 upon reciprocal, like that is taken as a reciprocal. So for example, if we have log, let's say 2 to the power 3, 7, so it becomes 1/3 log 2, 7. Okay, so this power goes to the left hand side, becomes 1 upon n. Okay, so we will use this property and simplify this expression. So it becomes 3. Now this power comes on the numerator, this power comes on the denominator. Okay, of log k is 1, log k, and k base is also k, the argument is also k, that becomes 1. So it becomes 4, 3 into 4 by 3 plus n, this becomes 2 by 4, so n by 2, plus this becomes so this is equal to 8 times of this is 3 by 2. Okay. So this is 4 plus n by 2 is equal to 4, 3 is 12. So n by 2 is 8, or n is equal to 16. So that is the answer to this question. Okay, so logarithms is, if you need to master, just know these rules. Okay, there are rules of logarithms, go through it through any book or any other source. Like if you have enrolled in some classes, institutes, they must have taught you the rules. So just ensure that you write each and every rule. So when you solve a question on logarithms, keep the rule book ready and think, like that's how you practice. How do you master concept? मतलब लोग कहते हैं कि मुझे strike नहीं होता logarithm में कौन सा concept लगेगा, ठीक है, या फिर geometry में कहते हैं मुझे formula strike नहीं हो, कौन सा theorem लगेगा. The best way is keep that formula book, like maintain all the formula, maintain all the things, that what is the property when you put like log base power here and here, and write that. So whenever you solve questions, keep that notebook handy and see which all formula can be applied. So once you do it on a repeatedly basis, you will automatically remember the formula. So it will automatically strike that, okay, here this concept will be used, here this concept will be used, and you shall be able to solve all the questions with ease. So if you are preparing for CAT and other MBA entrance tests, we have launched our mock test series for the same. So we've launched CAT mocks that will include 15 full length plus 10 sectional each. Okay, and we have also launched a mock test bundle that will include mock test for apart from CAT, for NMAT you will get 10 mocks, 20 for SNAP, okay, 5 for ZAT, 10 for CMAT, CUET, okay, 20 for MHCET also, then ZAT, SRCC, XGMT, MyCAT. So we will cater to all these examinations. Okay, so you will get mock tests for all these examinations. So if you wish to buy the bundle, you can purchase it from our portal. Okay, so you can use this code HOT to get 20% off this month. So that would be a good place to practice for all these examinations. So as in the exams are announced, we will be launching those mocks and based on the latest pattern. Okay, so this was today's lecture that was on a couple of topics on algebra, logarithms and series. Next class we will be doing linear and quadratic equations and solving a variety of questions on that. Okay, so here are some questions for you to answer in the comments of this video. So solve these questions and do let me know in the comments the answers to these questions. And if you want the PDF of this series, just go to our Telegram group and ask for it. You will get the PDF of all the sessions over there. So this was day 17. I hope you have enjoyed the series thus far. Continue watching for the next 13 days also. And I guarantee you that if you have watched all 30 videos, और जो आपने सीखा है उससे आपको काफ़ी benefit मिलेगा. You will be able to scale your score in the examinations because you must have learned quite innovative ways to solving different sorts of problems. So that's for today's class. Thanks for attending the class and don't forget to like this video and share it with your friends.